Welcome to Get Your FRQ On. This question is from 2006. It's question 2, and it is calculator active. In the question stem, we're given a function L of t and its graph, and the function L of t represents the number of cars turning left at an intersection over an 18-hour interval. In part A of the question, we are asked to find, to the nearest natural number, the total number of cars turning left for t between 0 and 18. Okay. Well, the total number of cars turning left over that interval would just be the definite integral of the rate function from 0 to 18. And since we have the rate function, we can just find that integral. All right, so we're given that the rate function is L of t equals 60 times the square root of t times the sine squared of t over 3. Not a very pleasant function, but this is a calculator active question, and that's kind of the point. You are not intended to find and calculate this integral by hand. That's why it's a complicated looking function. They want you to use your calculator here, so by all means, oblige. Right? Use your calculator. It's a calculator active question. There is no point in leaving points on the table by not using it. If it's too difficult to do by hand, then use your calculator. The only requirement is make sure that you communicate clearly to the reader what it is you are asking your calculator to do for you. All right, well, we are asking for the integral from 0 to 18 of L of t dt. Which is the integral from 0 to 18 of 60 times the square root of t times sine squared of t over 3 dt. And the answer we get from our calculator, rounded to the nearest natural number, is 1,658. So there are 1,658 cars turning left from the time interval from t equals 0 to t equals 18 hours. In part B of the question, we are asked to find all values of t such that the rate function L of t is greater than or equal to 150, and then find the average value of L on that interval and to provide the units. Since we're given the graph of L of t, we can inspect the graph to determine when about L of t would be greater than or equal to 150, and based on the graph of L of t, this is true for some interval containing t equals 100, or not t equals 100, t equals 15. But it is a calculator active question. If we need to know the exact endpoints of that interval, we can use our calculators to find that. We have the function L of t, we have the actual definition of that function. So we can use our calculators to determine where the function L of t intersects the horizontal line y equals 150. And that would be true on the interval from t greater than or equal to 12.43821 and less than or equal to 16.12166. Now, one of the things that you can do in a free response question where you have decimal answers like this, where they might be like the intersection of two curves, and you're going to need that number later, they will allow you to label those points, like label one of them capital A, the other one capital B, as long as that doesn't cause confusion somewhere else in the problem where maybe something else is labeled capital A or capital B. But once you label those with a unique letter like A or B here, you can refer to those A and B later without having to rewrite the decimals that they represent. All right, so we know that the number of cars turning left is going to be greater than or equal to 150 between A and B. And now we have to find the average value of our function L over this interval. Well, this is going to require that we use our average value definition, which is an integral divided by the length of an interval. All right, so our interval is just whatever b minus a is, and the integral that we want is the integral whose lower bound is that value of a and whose upper bound is that value of b. So one of the advantages here to labeling those points, the endpoints of that interval with a and b, is it just makes it easier to write down what it is you're trying to do. All right, so I have the integral from a to b of 60 times square root of t times sine squared t over 3 dt, whatever that is, and then I'm going to divide by whatever b minus a is. But at this point, we've sufficiently communicated to the reader what it is we're asking our calculator to do, so we could just write the answer down. It's 199.426 cars per hour. In part C of this question, it's given that they're going to install a light at this intersection if there's a 2-hour interval such that L of t is greater than 400. And if it is, they will install a signal, and we have to determine whether or not a signal will get installed at this intersection. So mathematically, this is the problem that we are interested in. We need to make sure that this product, which is given in the question stem on the actual test, its product has to be greater than 200,000. If this product, 500 times the integral over that 2-hour interval, has to be greater than or equal to 200,000. Right? It's assumed that in a given hour, 500 cars are coming at the intersection, oncoming traffic. Right? It's this issue that is cause for concern if there's, a lot of cars turning left and not a lot of cars that are oncoming. Maybe that product's going to be less than 200,000, but if they're both really big, that could be a dangerous intersection. Probably would want a light. And this problem simplifies if we just divide everything by 500. We need to find, is there a 2-hour interval where the integral from t to t plus 2 of L of x dx is greater than or equal to 400? Now there's a couple of different ways to approach this. We can either try to show that no 2-hour interval like this exists. Not sure how you would do that, but that would prove that no signal would get installed here. Or we can find a single interval for which this is true, a single 2-hour interval for which this is true. And if there is one, that guarantees that the signal gets installed. So one of the easiest ways to prove that something is going to happen is to show that it happens. So is there a 2-hour interval where this product is greater than 400? Well, if we find one, yes. All right, so if we check our graph of L of t, right, it only needs to be true for one time interval of 2 hours, just one. Well, based on the graph of L of t provided, there's a maximum value of L of t near t equals 15. So it would make a lot of sense to use an interval that contains the highest values of L of t, because that would be our best shot at getting a product sufficiently large. So let's consider the interval from 14 to 16. All right, so if I do that interval, and I take the integral from 14 to 16 of L of x dx, that integral does have a value that is greater than 400. So over that 2-hour interval, that product would be greater than 200,000, and therefore a traffic light would be required at the intersection.